Hi geometry students, and welcome to our last week before Christmas break. I'm sure you are as excited as I am, and we are going to finish up this week with a chapter 4 review, and then you will take the test on Wednesday, so you will actually have ample time to review the chapter 4 test after you take it, the one in the book. Remember, we use that kind of as a as a review. So if you haven't taken that already, go ahead and take it, and then look at the review, because I want you to see how much you actually know before you take the review. Most of the questions that I've added into the test that I will give you on Wednesday have come from basically the template of the book test. I've added a few things, but everything that we go over today should give you the information you need to do well on the test. Remember, you may use your index cards. You may use notes that you've taken in class. You may not use the book. And you will be able to spread out on Wednesday, get comfortable, make sure you have your calculator, make sure you have a protractor, just so that you can measure angles if you want to. So just make sure you have your tools. I would also make sure to have some sort of straight edge. There will be graphing of some points and using the distance formula for those. So just make sure you have all of your equipment. There will be some table space, both in, I'm going to have at least one, possibly two tables set up. I will also allow some folks to possibly work in some of the small rooms. So if you want to work at a table instead of working on just your lap. So let's get started. Remember, you need to have taken the Chapter 4 review test in the book before you get started. So I have recreated the Chapter 4 test on this PowerPoint, and we will look at each section. I will talk about it. I'm also providing down here in the corner for you the page numbers and section numbers that this comes from, so that you can refer back to and study and make sure that you have all the blue box information written down. So what we want to do first is make sure that we understand the definitions of all of these items here. Remember, an obtuse angle has a larger than 90-degree angle. An acute angle is the less than 90 degrees. Equilateral means same sides, same length of sides, but equal angular means same length of, or same measure of angles. And isosceles is going to have two congruent sides. Now, you also do need to make sure you know the others that are not on here. The scalene, no congruent sides. Equilateral has three congruent sides. So there were more definitions than what are given here. Obtuse, acute, right, those are dealing with angles. And then you have equilateral, isosceles, and scalene. So make sure you know all of those definitions, because they probably will show up on the test somewhere where you will have to know them. So it says identify a triangle in the diagram that fits the given description. So first we want obtuse. So if KJM looks like it could be, but we're not completely sure, JLM would be a safer bet for an obtuse. This is where you could measure with your protractor if you wanted to. They want an acute triangle, and so JKL, this triangle right here, we know that there's no 90-degree angles. They're going to all be equal because we have three congruent sides. Equilateral is also going to be JKL because of those three congruent sides. And then isosceles needs two congruent sides. Here we go. 1, 2, JLM. So again, this is problem number 1 on the test. There might be a problem or two that I've skipped on the test, so don't trust that I'm giving you the right numbers on these. Okay, so the whole point from this, go back and make sure that you know these definitions. If you think you're going to mix them up, make sure you have them written down on your index card toolbox. All right, the next one, see this is 5. The previous ones that we did were 1 through 4, so don't let all of that confuse you. Okay, in the next 3 slides, I'm going to be solving 5 to 7, and it wants to know the value of x. Make sure you read the instructions carefully to know what they want you to do. We want to find x. And so what we probably want to do, we don't know any side measurements, so we can't get any of our information from what we know about the sides. However, we do have something down for each angle. X for angle Q, 3x minus 15 for R, and 2x minus 3 for P. So we know that all 3 of those combined would equal 180 degrees because we know through our definitions, theorems, that the total measures of a triangle are 180 degrees. So we merely just have to put them all together. X plus 3x minus 15 plus 2x minus 3. All 3 angles put together equals 180 degrees. And when we do the math on that, we are going to come up with 6x, and then we have a negative 15 and a negative 3, so we'll have 6x minus 18 equals 180. And then when we do all of the math on that, and I haven't worked it out for you, you can certainly work it out. 6x minus 18 equals 180. So we're going to add the 18, and what we will get is 198. And then you will divide all of that, and you come up with 33. I'm going to trust their measurements. So if you haven't worked this out, x plus 3x minus 15 plus 2x minus 3 equals 180. You do the math, and you should come to 33. All right, the next one, we need to determine this third angle. We have 2 angles, 78 and 54, but we don't have the third. Now, one thing they're going to trick you with here is thinking that you can use this somehow. And we will, but not quite yet. What we're going to do is figure out the third angle by adding 54 and 78 and subtracting it from 180. So when you add 54 and 78, off the top of my head, I don't know what that is, but when you subtract everything, you get 48. So this angle right in here is 48 degrees. So if you have a document, paper that you're using, you could write 48 right in there. Now, you're going to realize now that this comes into play, and you have supplemental angles right here. We have supplemental angles going on. So see how we're pulling back on some of those previous theorems, postulates, and definitions. Now we can say that 12x plus the 48 is going to equal 180 merely because of our definition of supplemental angles. Then if you use your algebra to solve for x, you will have 12x equals 132. That's what you get after you subtract 48 from 180, or x equals 11. So you find out that x equals 11. You'll know then what this angle is. We already know that this angle is 48. And make sure you show all of your work. Don't go online and get it solved and just give me an angle measure or an x value. I need to see your work. Without the work, you will not get the total points. Remember, it's not just 1 point for the answer. You get multiple points for showing the work and then the answer as well. All right, with this one, we have a little more information. We know that all of these sides are equal, all three of them. We're not being asked an angle measurement. We are just being asked to find x. Now, since I know that LM is equal to LN, I can actually just set them equal to each other. And that's what I'm going to do. 5x minus 10 equals 15. I know they're equal. And when I work it out to solve for x, I'm going to get 5x equals 25, or x equals 5. You can just as easily set 3x equal to 15, or 3x equal to 5x minus 10. Any of them will work, and you will get the answer of 5. All right. Now, this one says, find the length of the hypotenuse in the triangle shown. Use a calculator to round your answer to the nearest tenth. Now, you know from algebra when we studied squares that they don't always, or square roots, they don't always come out to be exactly equal, and that is going to happen in this one. So we need our Pythagorean theorem and distance formulas for the next couple of problems, so make sure you have those written on index cards that you know how to use them. You will be using the Pythagorean theorem in this one, which is c squared equals a squared plus b squared in a right triangle. Since we don't know what c is, if we are looking at the hypotenuse, it is the one over here. Ln is the hypotenuse of m. We don't know what that is, but we know what the two legs are, 10 and 14. So we are going to add a and b, so 10 squared plus 14 squared equals c squared. Just like algebra, we're solving for an unknown. The total when we add 10 squared and 14 squared is 296. Then this is where it's helpful on your calculator to hit the squared symbol, and then you can find out that decimal value. You can look in the back of your book. There is also a chart that has all the squares. You may make a copy of that to keep in your notes to use, but I think it's just as easy to use that squared symbol. You do need to start knowing what the symbols are on your calculator and how to use them, because when you get to Algebra 2 and you're using a graphing calculator, you have a lot more stuff on there that you're using. So the answer to this one is 17.2. We can write that here across this line, but use your Pythagorean theorem. Okay, let's move to the next ones, 9 and 10, and this is where we're going to use the distance formula. I've put it right down here in the corner for you. I strongly suggest that you'd have it in your note cards. I know I say that over and over again, and you get really tired of hearing it, but it is helpful to have. Now, I didn't work out all the math on this just because creating the symbols for all of this on the computer, I'm just kind of lazy, and that was a lot of work. So, what you will have to do on a test is just plot the points. On the test, I've given you some graph area to plot the points, and then you will have to figure out the distance between them. So I'm testing you for two things. One, I want to make sure that you know how to plot those points still. It's been over a year, so make sure you're plotting the points on the graph paper that I provide. It's just a little graph on the test. And then you have to do the distance formula on these. So you're getting points for plotting. I want you to draw a line between them, and then you are going to do the distance formula. So when we plug in the totals, for the first one, it's -6. This is your x. This is our second point for x. -6 minus 0, and then -8 minus 0. When we add those, or when we end up with -6. -6 times -6 is 36. -8 is what we're left with for the y's, and -8 times -8 is 64. Don't let the panics or the negatives panic you, because when you square them, they come out positive. 36 plus 64 equals 100. Squared, the square root is 10. Then for the second one, here is our x sub 2, negative 2, minus 2, 6 minus 4. Negative 2 minus 2 is going to be a negative 4. Negative 4 times negative 4 is going to be 16. 6 minus 4 is going to be 2. 2 times 2 is 4. So there's where I came up with all that. It comes out to 20, and when you hit the squared symbol on the square root symbol on the calculator, you come up with about 4.5. Use your calculator if there is no perfect square. So that's how you will be doing this. Remember, you're going to plot them, draw a line between the 2 points. It probably is a good idea to label them so I know which one is which. And then you will be figuring out with the distance formula what the distance between them is. Do not use the squares on the graph to tell me the distance, and do not measure with a ruler. I want you to use the distance formula, and I need to see the work for that. All right, now it says here in the triangle shown below, this is number 11 on your book test, is the triangle shown below acute, right, or obtuse? Now, you will be using page 200, converse of the Pythagorean theorem, and there's several things there that you need to remember. So we are using this, but remember we had inequalities pop up. So c squared is less than a squared plus b squared, then we have acute. When c squared is greater than a squared plus b squared, then it is obtuse. And if c squared is equal to a squared plus b squared, then it is a right triangle. Remember this. Write it down. Use all of these formulas if you need them. But in this case, when we do the math, it is 17 squared plus 18 squared, and then we have to figure out what it comes out to be, what 24 squared is, and if, I don't think I did my math right, so let me do the math real quick while we're here together. We have 17 squared being 289, so I'm going to write that as we go, 289 plus 18 squared, which is 324, that comes out to 613. Then we need to figure out what 24 is. 24 times 24 is going to be 576. And so that's going to be 20. Let me write this over here so that you can see it. So I have two numbers, 576 and 613. This is the c squared. So c squared is less than a squared plus b squared, which means that it's going to be acute. So I don't know what I did there before, but these are the correct numbers. 613 is greater than the 576, which is going to make it an acute triangle. So just make sure you have those formulas in case you need them. Now, I am not actually doing any of these questions on the test, but I did want to give you the answers in case you needed those. And you can set this up and use the converse of the Pythagorean theorem just like we just did, but I'm not doing any of these on the test. So the number 12 was obtuse and number 13 was obtuse as well. All right, the next one is where we're doing the centroid. And so remember, when we have a median coming from the angle to the midpoint of the opposite segment, then we divide this into half. These become congruent. But remember, with all of the angles then we end up with something in the middle called the centroid. When we have a centroid, we then begin to work in thirds. So if you can remember that you are dividing, so there's going to be one, like example for this one, the B angle. B to D is the 2/3, and the D to the line is going to be the 1/3. And so look on page 207, that's where this formula is. And you can always eyeball which one is the 2/3 and which one is the third. So they give us a total here. They say that EC, right here, the total line, is 33. They want us to find DC and DE. Now you could look and tell which one is the bigger one. That's going to be the 2/3. So DC is going to be 2/3 of 33. So you have to know how to multiply your fractions. 2/3 times 33 is going to be 66 over 3. If you can see that in your head, and that will equal 22. And then this is just going to be 1/3, and it will be 33 over 3, which equals 11. So you either need to do the math in your head or do it with the fractional formula. So refer back to 207 if you're having trouble with that. All right, this should be pretty easy, naming the sides from longest to shortest. It works right in conjunction with the biggest angles. So the longest side for angle 71, that's the largest, is going to be AC. The second largest, BC. The third largest, AB. All right, then the next part is actually going to pull all of your previous knowledge so that you can find angle measurements based on some of the stuff that you've learned in the past. This says find the measures of all numbered angles in the figure below. So I began by looking at this triangle here, the one with 44 in it. And I know that I have another measurement here, 90 degrees. So I added 90 plus 44. And then I subtracted that from 180, which came to 46. So you have 90. That means that this one plus this one also have to equal 90. So I can use a number of my theorems and definitions. I know this is 90 degrees. I can add these two, subtract them from 180. Or I could say that 44 plus question mark equals 90, and then do the subtraction. So we find that angle fairly easily. Now if you're looking at this and think you can use supplemental, no you cannot. It is not a straight line. It is a crooked line, so be careful there. However, I know that this side and this side are congruent, which means these angles are also going to be congruent angles. So I will add those up. I come up with 62. I then subtract that from 180 and I will come to 118. So make sure that you have all your triangle information so that you can use definitions and theorems. And I am asking you on the test to tell me why you're doing things. So you'll have to fill those blanks out as well. All right. I don't, this was not on the chapter test, but I believe it's on the little test that's next to it, the standardized test. But I wanted to take a look at this. So make sure you're paying attention. I don't think you've done this. But first it asks, what is the sum of x and y? So you have to use some reasoning here. Why are x and y 90? Well, because this is a right angle. So I know this is 90. That means that these two added together have to be 90. Then it moves on to ask me which measure is greater, x or y. And I have to use my side measurements now. And I use those definitions, and I know that x is going to be bigger because the 10 is bigger. And then finally it asks me to look at some information about Z, and it wants to know which one of these statements down here is true. Well, it wants to know if Z equals 90 degrees. Well, no, it does not. It looks like it's an obtuse angle. It wants to know if Z is less than 90 degrees, and again, because it's probably obtuse, it can't be less than 90 degrees. It asks me next, is Z greater than 90? It does appear to be so, but let's take a look at J just in case. Is Z equal to Y? Well, this is acute. This looks obtuse. You could use your protractor just to check, but I believe that G is going to be our answer. And then finally, another one of the standardized test. In the triangle, what is the value of X? Well, we did one that was similar to this. I have congruent angles, which means that I have congruent sides. This is another one of those where I can just take this side and make it equal to that side. Therefore, I'm going to have x minus 3 equals 4. I'm going to add 3 to both sides, which means x equals 7. I don't have any multiple choice on the test, but just wanted to do one more practice problem. Okay, hopefully that helped you maybe tweak some things. On Tuesday, I am available much of the day. I have tutoring from 1 to 2, and I do have a morning class. From 2 to 4, I am available. So if you would like to ask me any homework questions, I will have a Google Meet open, and you are welcome to check in at any time between 2 and 4 on Tuesday afternoon. So I'll have it open that whole entire time, and we'll be doing some other work. And if you, for some reason, I'll have the Google Meet on the HAS and on our school page. And if you, for some reason, cannot get me, then text me at 301-788-5457. And I will see you in class on Wednesday.